Hi everyone. This should be the live broadcast from the HTTP2 team meeting. I'm Matteo Collina speaking, and there is also James Snell here.
Yep.
So first of all, let me check if all of this is working. Sorry, it's my first time doing this live streaming, so I don't know, I don't have a clue. Yes, seems working.
Yeah. Everything
Awesome.
seems to be good, going good. So I guess the first thing to discuss would be the rewrite of the internals that I did around 8. It's much more efficient, taking advantage of the event loop, and doing less per tick, basically, queuing things up, and then each time the event loop goes, it does all of its I/O or triggers the callbacks and that kind of thing. So it's much more efficient. We're able to get a much higher throughput. Where things break down, of course, is when over on the JavaScript side, the multiple levels of streams that we have between the request and response objects and the stream duplex. So your idea of doing something that is more specific, more optimized for HTTP2, and then allow, and then do the higher level things later on, I think makes a lot of sense. And let's just get the performance working just for that lower level, the stream interface.
So it is my point of view here. It's the fact that when so we need to provide HTTP2 for 2 reasons in core, and the first one is of course being able to write web applications, okay, but also as a transport for microservices system like in gRPC or other kind of things where it can be used. So it's critical that we get a very fast implementation. Now, all those all the bell and whistles for most of the HTTP things and semantics is not really needed. They need a lower level protocol. Okay, right. So now the problem relies on the fact that we still want the end web application thing go fast. So this is where probably the contention is going to be.
Right. But I think that if we start on optimizing the HTTP2 stream and HTTP2 session classes, and focus on those as much as we possibly can, with keeping in mind the types of hooks that we're going to need for the higher level interface. So doing things like, where we can specify that there's not going to be a body for a response, so we can skip having to do any kind of data frame. There's going to be some optimizations that we provide hooks for. If we keep those in mind, I think that we can still optimize for the lower level API and make it possible to do a higher level API that at the very least is not worse than the current one in terms of performance.
So regarding that, I did some digging into the HTTP1 API. And its intern is not using any of the, it's not using streams2, it's not using readable or writable. Right. And one of the reasons for this is a lot of the buffering is done internally, okay, on this previous socket level. And it's avoiding to do that buffering makes sure that, in fact, we can deliver greater performance. Yep. So as a side note, if you are interested, I did a little prototype of something different from different needs, but it might be of interest for you. It's called sync through. It's you can find it on npm. And it's an implementation of transform, okay, that doesn't do any buffering.
Okay, cool.
It might be now it might be of inspiration, or now we want to handle things, especially if you look at the pipe method inside that. It's over here.
Yeah, and there's a couple other things. I mean, doing that I think is absolutely the right thing to do. If we continue to view HTTP2 stream class as a duplex,
Yes.
right? And it does its writing directly into the native side, which has to have its own buffering also. And then as data is coming out, there's two levels of buffering. One is the data is being pushed into the callback for notification, and then on the event loop, it pushes it out into the duplex instance. So data is being buffered twice, outgoing and incoming. I don't think we're going to be able to avoid that, but if we can avoid it, the HTTP2 request and HTTP response, then absolutely, and we could just rely on the buffering that's happening in the duplex.
So just let me rephrase if I understand it correctly, okay? So in the current system, as it is implemented right now in your latest PR, we have 3 levels of buffering, okay? One is within readable and writable for HTTP request and response.
Yes.
One is at the HTTP2
stream,
which
is a duplex, yeah.
And then there is, which is a duplex, and then there is at the underlining socket, right? The underlining.
Well, there is the native code, the bridge layer between the JavaScript and ng-HTTP2. It implements buffering because of the way ng needs to multiplex the data. Basically, when you do a write on the duplex, right? The write v and the and underscore write, those methods do a write request into the native code that puts the data into an internal buffer where it sits until ng is ready to actually send it on the socket. And then when the data is ready to be sent on the socket, that data gets packaged into frames and then passed to the socket implementation, which obviously has its own buffering.
Yeah. Well, but
we cannot avoid that buffering at all that happens. The buffering that happens in between our job, the HTTP2 session and the ng-HTTP, we cannot avoid that buffering at all. It's mandatory.
So it's for me, the most important piece of things. It's try to avoid as most buffering, multiple buffering inside node.js streams. Okay.
Yep.
Each level of buffering cuts the throughput.
Yep.
There's a lot of code in there, especially in streams too. Okay.
Oh yeah.
So in order to deliver a decent performance, we will need to. We might want to say we just inherit from stream, like HTTP2 stream. It inherits from stream. It doesn't inherit from duplex. Okay.
Right.
Now, I'm not saying we should do that. I'm just saying it might be an option.
We can. The only issue there then would be being able to do the back pressure. Right now, the internal buffering that occurs doesn't implement any back pressure. It just takes whatever it's given. It's relying on duplex to provide the back pressure necessary. If we implemented some kind of back pressure mechanism in the native buffering, on the native side, then we could have HTTP2 stream extend from stream and eliminate a great deal of that code. So I think that is definitely an option.
So just your PR is really good at the moment, so I don't know if what is there in the previous code or not. It's are we using stream-based class?
Yes. So the internal HTTP2 session, the one that's available through the process binding, is it extends from Streambase.
Okay. Yes. And sorry, I'm trying to understand exactly what's going on here, because it's all those moving between things it becomes more complex.
Oh yeah. Oh yeah.
Then what? How much I would love it's really. So okay, so we have the HTTP2 stream. So the HTTP2 session is named from string base, but it's sorry, I'm lost on the terminology here.
Okay. So there are several classes on the native side. So through the process.binding in
Yes.
the new PR, there
Yes.
is a native HTTP2 session class, right?
Yes.
It provides a bridge to ng HTTP, right? It inherits from Streambase.
Okay.
Okay. Now, what it does is it will take data from the JavaScript HTTP2 stream class. Okay.
Okay. Perfect.
Now, or the from the HTTP2 session class.
Yes.
Right, which is the HTTP2 session class on the JavaScript side is not a stream implementation. Okay, it's just a class. HTTP2 stream, which is a JavaScript class purely now. Before there used to be a native, but now in my rewrite there's not. It is a duplex. Now, that duplex implements write v and write. The implementation of write v and write tell the JavaScript HTTP2 session class to call in and write data to the internal HTTP2 session object.
Okay, but no, so if I understand currently, the only buffering level here is in HTTP2 stream.
On the JavaScript side, yes.
Yes. Okay.
Okay. Now there is buffering internally on the native side because we have to. We can't just write it directly out to the socket or anything else. We have to hold on to it until ng is ready to write it out to the socket.
Of course.
Now that's an HTTP2 stream. Now at the higher level API with the request and response objects.
Yeah.
Right. Because the existing HTTP2.1 or HTTP1 implementation has separate request response objects. That's the only reason why I'm introducing them here, is to keep the API parity. Okay. Those are separate objects. One is a readable, one is a writable.
Yeah.
Right. What those simply do is forward the data on to HTTP2 stream duplex. Okay. So the readable side of the HTTP2 stream passes it to request, and the writable side or the writable HTTP2 response forwards its data onto the writable side of the HTTP2 stream duplex. So there's buffering going on there, and that's what I'm hoping we can eliminate. Now, if we can also eliminate the buffering that's happening inside the HTTP2 stream duplex by making that be, inherit from stream instead of duplex,
yeah,
then we will improve performance even better. And that way we'll only have one layer of buffering, which is happening at the native side. Right?
Yes.
So, and what that basically means is on each loop, each event loop tick, all of the buffered data heading out, outbound buffered data will be dumped, and all the received data will be passed back to the callbacks of all the various HTTP2 stream objects. Okay. Without any additional buffering happening. So it should, all of the data should be purged on every loop rather than the
Yeah,
buffering that
that
we have
would
now
be
where
that.
it could be spread over multiple.
So okay, so from an actional point of view, okay, now I understand all what's going on in there. So I think we should probably just get this merged at this point, and maybe start like decoupling the request and response, the current implementation request and response from here. Okay.
Yep.
And move them to to their own thing, so that to their own file, maybe in internals or whatever. I have no idea, but it's better to let's separate things. Okay, so it's let's focus on getting a very fast duplex thingy, and on the parallel, I can probably start to getting down and reducing those numbers on the JavaScript side for readable and writable.
Okay. Okay, so I'll do that. So right now, I moved the implementation out to a hp2.js under lib in order to change that. But what I'll do, if we're going to separate these out to separate files, I will create a new folder under internal/hp2, and I'll have a separate one there for just the stream and another one there for the high level interface. And then we can import those both on lib hp2 stream and and export the necessary API there. So I'll work on that over the next couple days. So I'll get round 8 landed. I'll work on splitting those out. We're kind of overdue for rebasing off of master.
Yeah.
So I'll get a PR that pulls in all the latest commits on master and get that landed. There was also an update to NG, the NG library that we need to pull in at some point here. There's no breaking changes. It's just purely additive. So that should drop in, no problem. And then we can start streamlining the stream interface. And
so I have one question.
Okay.
Yeah. So is the problem on the read side, or is the problem is on the write side, right? Not on the read side.
The read side's pretty straightforward. On the read side, as data is received on the socket, it is passed to NG, which goes off and fires various callbacks. Callbacks for like when a header block is received or when a data frame is received. Those callbacks are queued up, and on each tick of the event loop, those callbacks are invoked. So it could be, for any one connection, you could have, quite a few callbacks being called depending on how many concurrent streams you have. But they're very small chunks of data. In the stream base, what basically ends up happening is when a chunk of data is received, that data is pushed to the stream base and pushed out to the hp2 stream socket. Or no, it's not socket, the hp2 stream class.
Yeah.
Which just forwards it on to the hp2 request. It's very efficient. It's just a couple of callbacks that just kind of push the data out. So as long as the hp2 stream duplex and the hp2 request readable are in flowing mode, that data just goes right out quick. If those things are if either one of those get paused, then the data ends up getting buffered a couple of times, based on whichever one is paused.
Seems really straightforward. So so on the HTTP1 kind of things, the incoming message, the request, is unreadable, while the outgoing one is not a writable. It's just a stream.
Right.
Because of that, it doesn't do any buffering. So you can just leverage the buffer that is underneath. So it might be an approach that we can follow on the higher level.
Right. Hold on, I gotta go shut up my dog. She's barking
Yeah.
outside. Crazy. Hold on.
It's nice that my dog is not shouting at your dog, so it's going to be, that's going to be fun.
Okay, sorry about that.
So, there is
so
one more. Yeah, go ahead.
yeah, so yeah, the flow of data is really straightforward. The only thing that really complicates it is the fact that we just can't write directly out to the socket. We have to wait. So there has to be buffering. The trick though is making sure that we can clear the buffer as quickly as possible on every event loop. Every tick of the event loop. And then reducing the number of times that we have to buffer. So if we can eliminate any buffering on the JavaScript side, and provide the necessary pushback on the native side, when the buffering there, then I think we're good.
Yeah. Well, I think we might be there. Yes, I absolutely agree. There is one more question that I don't know if you have any news on that. Is the client side of things, because we will probably need to start adding testing.
So the client side, I need to have a follow-up conversation with our friends at Google. They had a couple folks that were going to be looking at that, but things have been so much in flux. I think they're kind of waiting to see when it settles down. So I was going to reach out to them next week and see what they want to do there. It is possible from like a test point of view, we could put some fixtures together that basically simulate a client-side session. You know, all we have to do is open a socket and send it a bunch of
yeah, I know,
binary data, right?
Yeah, but it's there is a lot of the it's not a maintainable approach. Okay, so
I know.
I don't want, we don't have so much time to work on this, so I would rather prefer to have some
actual client,
have an actual client, so we can just more or less testing ourselves. So if we can be self-hosted, because at this point it's hard for other people to contribute and join the work.
Oh yeah.
So the moment we start saying, look, there is one client or the other, we can we can have more people collaborating. So
now, one possible thing that we could do, as far as testing and benchmarking, we could look into whether we can build the ng HP client and H2 load tools and run those as part of the test suite. So when ng builds right now, it's only the library, right? It's none of the tools. We could build the tools and use H2 load to do benchmarks and ng as a client.
yeah, it might be actually a very good approach for providing some automated benchmarks to the benchmarking suite.
Right.
Because we're currently doing the same with WK, so for H1. So it might be.
We would just need to to add the full ng distribution to the dependencies. Right now, it's just the lib classes. So it increased the footprint of the dependency in the tree, and we would have to make it update the JIP so that it would actually build those things.
Yeah.
But that would be an option too, and using those, we'd be able to at least be able to get started on building tests, and then when a programmatic client is actually developed, we could switch the tests over to using.
Yeah, well, the test, the client needs to be if the current plan for us is still to ship this in the next node major. Yeah. We need to have a client as well. So it's if our friends at Google don't have time, or
then we have to jump into it. Yeah.
We will need to make time to get this done, because it's critical for the ecosystem to have an HTTP2 implementation that is extremely performant in Node.js. So
yep. So okay,
I will put down.
I do need to run.
I take down some notes, so I will write a couple of points, a couple of action items on the thing, and feel free to add it on whatever when it's done.
Okay, all right, sounds good.
Thank to everyone that watched this, and see you soon.
All right.
How you close it?
Bye.
Bye bye.